Hello, everyone. Welcome back to a new episode of Advent of Code. It's finally here, the day where I proved to everyone I don't actually care about leaderboard points by starting almost 20 dang minutes late. All right. So with that exciting announcement, let's get started, shall we? Day 5. Sunny with a chance of asteroids. You're starting to sweat as the ship makes its way toward Mercury. The elves suggest that you get the air conditioner working by upgrading your ship computer to support the thermal environment supervision terminal. I don't know why those words were so hard to read. I think it was because I was trying to figure out what the acronym was as I was reading, because it's always some acronym. Could have looked down to the next line. Anyway, the test starts by running a diagnostic program, your puzzle input. The test diagnostic program will run on your existing Intcode computer after a few modifications. First, you'll need to add 2 new instructions. Okay, we have opcodes 3 and 4. 3 takes only 1 input, saves it to the address given by its parameter. What's the difference between inputs and parameters? Okay, we get to parameter modes later, I guess. Oh, this is going to be a long one. Okay. Opcode 4 outputs the value of its only parameter. For example, the instruction for 50 output the value at address 50. Okay, programs explain what should be connected to input and output. Okay. Parameter of an instruction is handled based on its parameter mode. Right now, your ship computer already understands parameter mode 0, position mode, which causes the parameter to be interpreted as a position. Right? Now we also have parameter mode 1, which is immediate mode. Parameter modes are stored in the same value as the instruction's opcode. The opcode is a 2-digit number based only on the 1s and 10s digit of the value. Okay, the opcode is the last 2 digits of the number, and parameter modes are single digits left to right to left from the opcode. Wild. Okay. Any missing modes are 0. Okay, so for this reason, this has been true already. We just didn't know, right? Because all of our opcodes in the last thing had no parameter mode and therefore defaulted to 0. Okay, this is a multiply where these two are in position mode and this is in immediate mode. Does that even make sense? No, hang on. 0, 2 is a multiply. These two are the only parameters. We read from position 4 and right and multiply with a constant 3 into position 4. Is that right? The value at address 4, immediate mode, stored. Okay, got it. Integers can be negative. Yeah, of course, the instruction pointer goes up by the number of values in the instruction. It will start by requesting the ID of the system to test. Give it 1. It will then perform a series of diagnostic tests confirming that various parts of the encode computer function correctly. For each test, it will run an output instruction indicating... Okay. Finally, it will output a diagnostic code and immediately halt. An output followed by a halt means it finished. And if all the outputs were 0, then it was a successful finish. Got it. So we should expect some outputs, and we hope they're all 0. And I imagine part 2 will be like provide a different input and then measure the diagnostic outputs somehow. Or the tests rather than just the diagnostic code. Okay, so there's definitely some stuff we could reuse here from day 2, but as I mentioned during the implementation of that day, I wasn't very happy with the abstractions that I had in place. So I'd like to build a more principled library for an int code interpreter. I'm definitely going to go back and borrow some stuff, but I do want to start sort of fresh. And I still, don't properly know the right way to make a test that can be used, or a reusable library. I think a reasonable step would be to I don't know. I don't want to, again, try to figure that out on camera. So I think I'll just write int code as part of this day's solution and then figure out how to turn that into a library overnight or something. So what I think we do want, though, is, let me just look at my Cabal file here. What the heck? Main is main.hs, but it compiles everything else under source. So we can put any files we want in there and it'll be fine. What was I? Yeah, so what that means is we want do they capitalize int code, the C in int code? They don't. Okay. All right. So we want module int code where. Yeah, you have to put a where. Yeah, it's been so long since I wrote a module declaration. We need some types for things. We need a lot of them. So let's start with actually, let's go back and refer to day 2, part 2, where they gave us actual names for some things. So we have a memory, right? We have an address. We have an instruction. Yeah, we should use those words when defining the types here. So type address equals int. That seems reasonable. Really, I should figure out how to use data.vector as well instead of using intmap again, but I'm not going to. Or actually, is it in, yeah, it's in a different, vector's in a different package, so whatever. Well, okay. I should at least look at the API. If it's easy to use, but it's not. I don't know. Well, okay. For unboxed arrays, which I don't really need, although I just have boxed ints, so in principle, I could have unboxed ints, and I think that would be pretty reasonable, actually. It's not necessary, but it would probably be the best way to store it. So what's this about strict and, do we have strict and non-strict? No. We just, mutable or immutable? Well, how do what are the kinds of, okay, m vector is a mutable boxed vector living in IO or ST. Okay. So how do you make a vector? I really should learn how to use vectors, so let's at least have a look. Empty, singleton, replicate, generate. So they all, they don't all necessarily have a fixed size. That's interesting. So can you change a vector size? Modifying vectors. update. Indexing. Maps and zips. Partitioning, yeah. And then all the kind of fold operations. So I don't see anything for... It's kind of weird, isn't it? That it doesn't say that vectors have a fixed size. You might guess that they do, but it doesn't say so. And you can build them without having a fixed size in mind. Somehow I lost it, but... Oh, there's subvectors. Okay, so that's... Maybe I just skipped past the part. No. Okay, I guess you do need a size in mind, right? They don't all have an int, but the size has to be 0 or 1 or a fixed size. And then there's no way to, like, add new elements. Okay, I mean... I feel like I should at least give this a try. Concatenation. Oh, there it is. I didn't think I wanted to concat vectors, but okay. So, but this is like this is a linear time, so it's very expensive, but you're allowed to do it. Got it. Okay. So let's just add a dependency on vector. Like, why not? Is it gonna load? I bet it's not. My experience previously has been that I have to run stack by hand there for some reason when I add a new dependency. Okay, and now? Alright, whatever. So yeah, I think we should use a vector and not an int map. An int map is just silly. When that's exactly what vectors are for, right? If it were sparse, yeah, int map, but it's not. And so that's exactly what vectors are for. So what next? We need... type memory, I guess, is just a v dot. Well, actually, should I use an unboxed one? I can't imagine I would ever need them to be boxed, right? So, oh man, the API for unbox vectors is a little bit more like complicated. There's like this data family of vectors which I don't understand what any of this means. Vector int. Okay, but hopefully this all doesn't really matter to me. We just have like our type parameter, just like we have to be able to present a certificate of unboxedness, I think. Yeah, let's just try using this and see how it goes. Compiles. Okay, so like what is v dot, I already forgot, how do you make these things? V dot replicate 5, 1. It defaulted to double for some, what? Oh, because I didn't say I wanted it as memory. Yeah, okay, so we get a vector that prints like a list. And we don't need an M vector or anything. Although, like, putting an S in ST would probably be pretty cool. I don't know. It would be nice to be able to get like a series of all the previous states, which you can't easily do with ST, I don't think. So where how do you modify? Okay, so that is linear. It's not like a persistent vector like in closure. Modifying a vector takes linear time. Boo. Well, that seems pretty wasteful, doesn't it? Maybe we should use an int map. Or put it in S, but I don't want to be stuck treating stuff as mutable for no good reason. I don't know. On the other hand, like, when do I ever look at the past states? It's just like all the time, right? Like, it would be really nice to be able to, in this general library, produce a thing that like writes all the states that a program has had. And the vectors will always be smallish, right? They have to come into us as inputs. Sorry, I guess I don't know. I should show you this, even though I'm not really looking at anything in particular. Yeah. Because, like, I want to be able to say things like, you know, what was the state of the whole thing? But I don't know. What were all the states the machine visited is, like, really important for debugging. It's not important for actually running the program. We don't need past states for anything. I mean, we could use a mutable vector and then copy it a bunch of times, but that's just dumb. So, I don't know. I think we'll use an immutable vector and just pay the linear cost every time we want to write to it, which is kind of stupid. Safe, destructive, right. Modify. Whoa, what? Oh, how cool. So when you modify, you don't just give it like an index you want to write or something. You give it a function that operates on mutable vectors, and then it applies that to your ordinary immutable vector in place if it can prove that you don't have any other references to the thing, and with copying if you do have any other references. That's pretty neat. I mean, either way, you're like, if we want to look at past states, we're paying for it. But if we never look at past states, so maybe we can write, I don't know how smart this thing is, like, we can probably write our library in a way that we have like a do next tick that we can probably take advantage of unsafe updates is what I'm thinking, and still have access to previous states. if we just have one function that like ticks once, and then we have built on top of that two different functions. One that gives you all the ticks that have ever occurred, in which case we'll pay for copying, and one that just gives you the program's final state and like, I don't know, a list of outputs or something. And that one would use the unsafe updates, actually, I suspect. All right, so we'll use an unboxed vector, I guess. Why not? Is this dumb? I'm going to be getting boxed ints anyway from the input, and I'm not doing very difficult operations on them. So like being able to avoid the boxing fee is pretty silly. I don't know. Let's not do it. Good news, we only have to change that one. If we want them boxed again, we can just do this since we're only using ints anyway. Okay, so I'm just putting this off. We haven't done anything yet. Okay, we have to define like opcodes and instructions and stuff, right? So I guess what we kind of want is I think we want an opcode and an instruction to be different things. An opcode describes the kinds of instructions that have this opcode. And an instruction is an actual instance of one of these. So I was thinking something like add mul You know, we even need a little bit. Okay, actually that was fine. Opcode equals add or mul or I've already forgotten the new ones. Input and output. Okay, so let's get day 5. What's the opcode for input and what's output? I didn't think I need to show you guys the screen because it would just be so simple that but it's just taking me forever to find the friggin' thing that says, okay, what is an input? Opcode 3 is an input, 4 is an output. Okay. And what I want then is data operation to be an operation which contains an opcode and an int, which is a number of numparams. It's still very weird to me, by the way, to write things like this, but that's just how Haskell people do it, so that's what I'm doing. Right, so we have codes for opcodes. And those are just like the raw numbers, basically. What do you call this? It's not a number. It's like a... It's not the index. It's like... I don't know. In some ways, it's like the code number. We already have a thing called outcode here. And it's like, I want 0 to live here, right? I'm only going to define 5 operation values in the entire program. 1 for add, 1 for mul, 1 for input, 1 for... and so on, right? I need a place to store the number 0 associated with the opcode add. And I'm aware like I could use enum or something, but it doesn't work for halt, so... identifier. Fine. And let's define right now m.fromList an operation add. Let's swap the order of these two. 0, and it takes 3 params or 4? I think only the inputs count as parameters and everything has an output. Is that right? Number of values in the instruction. Okay, so what? Takes a single integer as input. It has 1 parameter. Has 1 parameter. Okay. I've already forgotten why I wanted to know this. Oh, so I could say how many parameters add has. And it has 3, right? 2 inputs and 1 output, and those are all parameters. Right? Okay, here they give us an example of a multiply. What is this, 33? Oh, this is a program. This is the first instruction, and this is some other, okay, some other opcode that's not part of our first instruction. So these are all parameters. Okay, so add has 3 parameters. Fine. Next up we have operation mul03, operation input 01, as I recall, operation output 0. Why am I typing a bunch of zeros? And operation halt is 99 with 0 params. What are you mad about? Oh. Is it like a from list width is the opposite of what I want, right? It's I guess what I want basically is index op for operation op as the operation this is kind of a dumb way to write it, isn't it? Yeah. I don't know, this is fine. Op identifier op for op in this. Yeah. So now everything's indented all funny. What are you mad about? Oh, sorry, here, why don't you guys watch what I'm doing? Couldn't match. Oh. There. So, and we might as well, in fact, derive show for this. For both of these, right? And then we can confirm opcodes, right? Opcode 0 is an operation named add, which is an identifier taking 3 parameters. And then we want like an instruction, which is an instance of an opcode that like has actual parameter modes and stuff like that. Oh, this is going to be a long one. I've like half an hour in and I haven't done anything yet. Just kind of want to model everything right, you know? So let's have an instruction. What exactly? I guess we kind of want like something like first of all, we want an inster of list of parameter mode, and then also like a per instruction set of fields. And I don't know what names to give all this stuff. Type oh no, data parameter mode. What are they called? Position mode. Everything's so friggin' long. So we want a binary data that has within it, I guess, a function from int to int to int. And then also like, I don't know, it really shouldn't have an arbitrary function, right? It should have like an opcode. I guess that's fine. It's a little bit weird because a binary operation should never have input as a type, but I think it's sort of all right. And I don't really want, I don't know. You know what? I should I should give that another type. And then it has source 1, which is an integer, right? It's not necessarily an address or a value. You know what, speaking of. So where are all the places I have integers that should actually be values? I don't see any others yet. Right, and so my thinking is that we'll put like an add op there or a mul op. And then we'll have something that can interpret a bin op. Let's just put this in my permanent copy paste buffer, huh? Oh god. Using record syntax for this is actually not that great. Because of like field puns and stuff. Yeah, let's just, I don't want to figure out how that crap works. And I'm not really going to be using those names to refer to it anyway, so. Or it's a, all right, what are the properties of input and output exactly? All right, you got lost. Input. 3 takes a single integer and saves it. All right, what the heck is my puzzle input actually? Oh, right, it's a program, of course. The input is like, we're going to provide a 1 here. So its parameter is the place that it is storing. Saves it to the address given by its only parameter. So there's no parameter mode for that, where you like look up where to store it in some other address, right? Okay. And this only basically takes immediate operations, right? The value of its parameter. Okay, got it. Right, and for what should be connected to input and output, that's kind of going to be part of the puzzle itself, not part of our program. So we don't want to model that exactly. Or else it's a union op? Mono op? Mono data, I guess? Now, mono op is a bit weird, but an int so input takes an integer value and output takes a parameter. Wait, now I'm not sure. Takes a single integer, saves it to the address given by its only parameter. So we've talked about by my understanding of parameter modes, opcode 3 given like this is in like position mode, and so 50 really ought to be interpreted as a number, you know, an address to read to look up another address and use that to store the value, because it's a parameter, right? And that's how you handle parameters, is you check the parameter mode. Each parameter of an instruction. Okay, I gotta look at some of these. Like, they have some examples with no. Aha! There we go. That's the sentence I've been dying for. No. Is it? Maybe it is. Parameters that an instruction writes to will never be in immediate mode. But, okay, I guess that sort of means that you... the instruction 450 outputs the value at address 50. Okay, so reads understand parameter mode. Opcode 4 knows about parameter mode, so like, if you saw something that was 14, comma 50, that means to just output the value 50. But 4, comma 50 means to look in address 50 and output that value. Opcode 3, which is input, doesn't have this distinction because it only writes, and writes never use that mode. Writes interpret the place they're writing to as an address, but don't read that address. Okay, I guess. I mean, that sort of like makes sense, but I wanted it to be specified to be sure I was doing it right. Yeah, these are honestly kind of like, it's kind of weird, isn't it? That like the binary op has 3 ints and the mono op has 1. Shouldn't it have 1 less? Like, this is kind of a nullary operator, right? Because it doesn't. You know, maybe I should. I'll call this a try-op. Like, because it has 3 parameters, right? Even though, like, it only has 2 inputs, the output is itself a parameter, so 3 is a reasonable number for that. All this show is making me sick, but whatever. Okay, so the idea then is, like, I didn't want to just reuse the opcodes here because it doesn't make sense for, like, for a try data to be labeled to contain an input, right? And that would be legal if we just put an opcode here. And I want to be able to write functions that accept a try data and know they'll be able to perform it in a reasonable way. So, like, how about what's a computer, right? A computer is a computer containing memory, which is a memory, IP, which is an address, inputs, which is a list of value, outputs, which is also a list of value. Maybe in reverse order? Question mark? Maybe I should use sequences? I don't know. I can read the outputs in whatever order. It's fine. And the memory is the programs, so I don't need to, like, store both of those. Right? Am I missing anything here? Inputs is a list of values not yet consumed. Outputs is a list of outputs produced so far. This seems like a reasonable type. Now, we haven't written any functions yet. I mean, obviously, all of these these data constructors are functions, right? Add is a function, mul is a function, but, like, well, no, because they're unary, but operation is a function, opcode is a function, you know, whatever. I guess these aren't really opcodes, they're operations. So I guess something that we kind of want next is a function that looks at a computer and produces I was going to say produces as output an instruction. I guess an instruction should also contain the opcode. It's a little bit weird, isn't it? or operator. Operation. It's a little weird because this is redundant, isn't it? The operation describes, like, in general, what this kind of instruction does. And that's useful because we want to know, like, how many instructions to skip ahead. But this data structure has the possibility of illegal instructions, right? You could have the operation for addition and the instruction data for multiplication or something, and that doesn't feel right. So maybe from instruction data, oh, well, you know what? I mean, kind of forgot something important here. Null data. Right? There you go. So, I mean, these are kind of in, like, not the best order also. Ah, what am I doing? So maybe we should just store the instruction data, and we should have a function that maps from an instruction data to an operation. And then it's still illegal. Like, you can't possibly... can't possibly represent an illegal instruction. So I feel like we really want like a function decode next or something, right? That takes a computer and produces an instruction. And, like, if we ever go out of bounds, I'm okay with crashing the program. I don't want to worry about the error handling. This has been a long day already, you know? Decode next. Now, how do you read a vector? Accessors, indexing, safe indexing, and non-safe. So I'll just use the non-safe one. Decode next of computer. I guess I need the memory and the IP anyway, so decode next C or whatever equals case, well, do I even really need the, like, number of parameters to be part of the instruction? I have to handle, I can't, like, use a list anyway. I have to actually handle 1 or 0 or 3 or whatever arguments. So, I don't know. I should just... Is that a legal way to write it, or is it the other way around? Oh, do I have to... like that? Yeah, okay. Why don't I write this? Is this legal and I just shadow IP? Yeah, I really do not care about shadowing. But it's gonna hassle me about it. Well, I don't actually need to do this. Case. Okay, how do you read like a subset of a vector? Like slicing. You get out a vector, which is fine. But how do you like look at a vector as though it were a list? ToList. Well, boy, if I'm converting things to lists, using an unboxed vector is pretty stupid, so I'm glad I decided not to do that. Okay, so let's... Case, what order are the arguments to looking up a thing? Accessors takes the vector first. I guess that makes sense. It's like a list. Case, mem at I of. Oh, you know what? I should be able to just look this up in operations. Yeah, so this is fine. But there's nothing to actually case switch on here. We get back like an operation, and we can like ask things about it. In particular, we can ask how many inputs it takes. But I don't really need that. It is such a hard, like, modeling everything correctly. Yuck. It just feels like this should come later in the year, you know? Later in the month, rather. I don't have time for this. So what I want out really is an instruction, right? Oh, you know what? I shouldn't even... I need another function first. Maybe it can be an aware clause here. But that splits an integer into its lower two digits and a list of like whether its higher digits are integer are 1 or 0, right? Let modes, no, code equal, first I have to look up, let opcode code equal this, inster num equal code, I guess I want mod 100, the lower two digits. And then we'll maybe work on the parameter modes later. But anyway, now we can say inster num. I guess we can just say this. Right, we've now decoded the information about these operations in general. And you know what just makes me mad? I don't think I need this operation type at all. I think all I need is an opcode. Because I can't do anything with just a number of parameters, right? Well, okay, so I need this map from int to something, but it could be a map from int to opcode, right? Because I'm going to need different cases for all 5 of the opcodes here anyway. Because there's no bridge from operation, which is like general and integer based, to any of these, which are specific and need a fixed number of parameters. So I think actually, yeah, and maybe that's why I didn't put an operation in instruction. I realized I don't need it at all. So I kind of need this operation, I guess, but it doesn't need number of parameters because I have to handle that separately anyway, which feels really bad to me. I feel like there should be some way I can handle it, but there just isn't because Haskell, I don't know. I could make an operation instead of having these 3 things modeled separately as taking a fixed number of ints, I could just make them all take a list of ints and only look at some of them. Maybe that's actually a good idea. It would really simplify the amount of ridiculous modeling I've had to do here. If we just took an opcode and a list of ints, which is the parameters, and you promise to only look at the number that you're supposed to look at. But since we have a vector, we can't even really give you a list of ints very well, right? Because a slice needs to be a fixed size and comes out as a vector. I guess we could provide you a lazy list of reading those values. That works okay. Yeah, so I think this whole business about having a separate constructor for each number of operators, each number of parameters, is just not really adding very much. So I'm not going to do that. So an instruction then is just an opcode and a parameter mode and a list of int. I don't think I should call it a value or an address, because you can treat it as either one. And now this operation type is actually very useful because it can tell you how many parameters you should read. Yeah, why not? Okay, so, and I don't need to change this operation type at all either. Okay, this is a little simpler, I guess. Parameters equals toList of, how do you slice things? Slice is a function, start index, then length, then the vector. Start index, which is and then the length, which what's the argument on num params of operation, and then finally the memory that we want to slice. Yeah. Wait, what? Yield at the first n elements without, what the fuck does yield at? Do they mean yield all? The others say yield all but. Without copying. I don't know. Slice is fine. We could give it actually a vector event instead of a list event. That seems fine. And instead of a list event, we could just give it a smaller memory. I don't know, maybe that's a little crazy. I don't know, I kind of like the idea of just giving it a memory that is like a smaller one. Sorry, here. Giving it a memory. Oh, it's mag, so I haven't written it in for my let. That's fine. So an operation also has an opcode. That's fine. In inster opcode operation, and then undefined for the parameter modes. Oh, that should be and then finally the memory, which is parameters, right? Opcode, apparently I made one word. So there you go. We decoded an instruction. And it turns out I didn't need this C at all. That's a redundant bracket? Are you kidding me? Really? I had no idea. I'm used to, like, if you need any spaces in, like, when you're pattern matching something, you need to put parens around it. Okay. But apparently these braces make it unambiguous, so you don't need them. Interesting. Funnily enough, we now no longer have, you know what, let's just, let's return an entire operation here. And now it'll be easy to look at the instruction and see how many parameters it consumed, so we know how many to skip as well. I really feel like we kind of want to reach for state here. But that sort of like defeats the whole purpose of my plan of yielding a set of computers. Yeah, I don't really want state. Okay. I kind of just want like a function called execute, which takes a computer instruction and returns a new computer. Right? That seems pretty okay. Execute, the new French word. I don't know. So the idea is that like execute It was nice to like have things in one way anyway. It was nice to have binary and unary operations set off from each other. Because then I could have add and mul share code more easily, right? But that's maybe not such a big deal. And input and output can't really share code anyway. We'll just decode it here. Inster of op modes params equals case. Yeah, it's easy enough to make them share. Case op of, right? If it's add, then run bin plus mul run bin times. Like that's all the duplication we need for these. We have to write run bin, of course, but that's fine. We can do that. Hang on, I need a computer here. Halt is, oh, you know what? Let's put a, easy. Running, there you go. So halt's kind of easy to handle, right? There you go. One case down. Input should also be pretty easy, I think. Is there like, oh, that's kind of a lens thing, isn't it? Haskell record modify function. I know you can update a field, but there's not an easy way to update a field like by applying a function to it, which is fine, I guess. Let's let i's be inputs C in C inputs equals i's. Write to head of params I. So something like this. So we need to implement writing, of course. But I think that's a good idea. So let's just give that a type for now. Write takes a value and address, and then a value and a computer, and returns a new computer. Well, it shouldn't take a computer, it should take a memory, right? Well, okay, it should take it, I don't know. It's kind of nice both ways, right? On the one hand, it shouldn't touch the rest of the computer, but on the other hand, it's nice to have this function here that does the unwrapping and rewrapping of the computer. You know what might even be better? Is if we had something that took a list of writes to perform and gave you a new memory, right? And this is actually, like, I think already in vector. Modifying list of index value pairs. Yeah. So we just, it's like this. I'm going to give it an alias for now, but it type checks. So that is the function that I wanted. So then what I kind of want is a function, I think, that takes a function from memory to memory and returns a function from computer to computer. God, typing is hard. So that's my thinking then, is that like this way we can kind of write, I don't know, this sort of handles the wrapping and unwrapping reasonably well, and then handling the writes is, I think, relatively simple. So why does this type check? There's no way this type checks. Obviously this stuff doesn't, maybe it just doesn't get here because it is mad about this first. So let's actually, yeah, okay, now it's really mad about everything. Oh, op. Good. So now all this write stuff is completely wrong. Wait, even this is wrong? Okay. What's the problem? This is a function. Write is a function from memory to memory, or from write returns a function from memory to memory. Ah, we want to update memory. That's why. So update the memory of C by applying this write to it, and additionally change the inputs of that result to have one fewer input in them, right? output. Output, we have to handle read like a... Okay, here's a funny joke. So when we're reading an operation, or reading parameters, when we put the parameter mode in there, I'm going to append an infinite number of zeros so that we can always assume that like the parameter modes are fully specified, and we just won't look past where we're supposed to look. So really the main thing that we still need is a way to read from a memory a parameter, read from a memory, produce a value given a memory, a parameter, and a parameter mode, right? So having said it out loud, oh, hang on. It's sort of like, oh, we'll just write a function of that type and see what happens. What is this warning about? Oh, yeah, it doesn't know what type run bid should have, so it's like guessing. That's fine. Honestly, I could have that function be inside the scope of execute so that it doesn't need to take as parameters. Like, it doesn't need to look at the parameter modes. It can take fewer parameters because it can close over the stuff that it needs. But it's sort of nice, isn't it, for it to be like out here? Read. Oh, it does need them because we're gonna be calling read multiple times. Okay, fine. Let's put it out here, I guess. Read is a function taking an address and a parameter mode and a memory and producing a value. Right? Oh, read is then it's shadowing something as well. Well, you know what? Oops. I meant to hit undo there. There we go. So now we can go ahead and shadow read to our heart's content, and we'll use prelude.read when we need it. Read. Oh, actually, we don't know that it's an address. Yeah, we do. Because we need to read from that address to see what parameter is even present. Oh, do we? Did we already read that when we decoded? We did. So the parameters have already been read. So it's not an address, it's an int, which might be a value, which we might choose to treat as a value or as an address. I feel like we should have a type that indicates like this might be a value or an address, but so far we're just using int for that. Oh well. So read is very easy when given immediate. We're already halfway done with read. Look at that. Read a, what's the other mode? Position, right? Yeah. And this one is also pretty easy, right? It's just mem a. Yeah. So we have wait, where the heck are the I thought our instruction had like the actual list of arguments. Does it not? I'm calling instruction. Oh, right. It has just a sub-memory. Oh, that's so cute. Right. So that's where I get the value that was in memory that needs to be passed to read. So this memory is the program's global memory. I feel a little bit silly, but like, what if I tried using phantom types to tag a memory address with how I plan to interpret it? I'm not gonna mess with that. It was just, I was like looking at this and I realized like we have a small memory and a large memory and we use the same type to represent both of them and you could easily get confused, right? So I don't know. Okay, so we need to implement run bin now. And run bin is just a write. No, it's update memory of write. And there's only a single write happening here. And it's looking at the third parameter, which is numbered 2. But what we write here is the output. No, the result. We need to define what the result is, of course. Did I already... Oh, run bin needs a function. There we go. Run bin of f. And the params are where the arguments actually are. I don't have to look at the program's memory at all for this. No. Params 0. Params 1. Right? What's wrong? Why? Oh, it has to be indented more than, yeah, okay. Yeah, but we can't just look this up. We need an int and a parameter mode. Oh, of course. We shouldn't be using v.lookup here. We should be using read. Right? No, we need to do even more. We need to say read. This is where you should read. God, giving us the parameters of vector blows. obviously I can just like look up parameter mode 0, right? And the program's memory. But isn't that super fucking gross? Like, wouldn't it just be better if this gave us back like a list of pairs, which are the parameter value and the mode with which you should interpret it? Seems kind of nice, doesn't it? Let's do it that way. So an instruction doesn't take a memory or a list of parameter mode. It takes a list of I guess these are sort of values. You can treat them as addresses if you want. I don't know, just call them ints. So of course this is the wrong type. It's a, we have a list of values, not a list of pairs of things, but we can add that later. And so now, I guess I can say let param immediate be, this shouldn't be modes anymore, it's these params. Okay. So this will fail at runtime if it doesn't, if like the pattern doesn't match, which is gross, but like that's life. So now I think what we want is like let a list of two things. Let's call them A and B. Oh. We can uncurry read and just A, B, C be params, I guess, right? I mean, I guess I'll take this as a pair, like, why not? Right. No, it's always position. Read a mem. Oh, I don't have access to the where. Yeah, okay, fine. Read bmem. So there's some type error somewhere. Why don't I see it highlighting? Oh, up here? Yeah, parameters has the wrong type. That's fine. I expect that. We could be very clever here if we wanted and avoid repeating the read and mem call with like something like f on flip read mem ab. Like this is the same. Nope, it's not. Oh, we would need more parentheses here, I guess. This is the same like expression, but God, it's horrible, right? I just feel clever when I write on, that's all. When I see a chance to use on. That is a chance, but it looks way worse, doesn't it? Okay, so run bin looks finished, I think. We just have to handle parameter modes. And we'll be almost out of the woods. And then, of course, the program will crash, and I'll be very sad. I haven't even written a way to, like, run more than one instruction. Okay, so... So what's the spec for modes again? It's like... Is the hundreds digit... No. The ones digit is the mode of the first parameter. So we can take the value divided by 100 and iterate with calls to mod and rem. No, those are the same. Mod and div, I guess. Okay, so let's write a little function. I don't know. Why am I writing a function? I'm only ever going to apply it to one value, right? So, take while greater, well, no, I don't want to take while because I want to have actual zeros forever. Oh, and I'll just sort of get that for free with iterate, right? Iterate, let's map mod 10 and iterate div 10 on insternum div 100. Zip parameters with modes. That's true. So we need a little function int2 mode. Of 0 equals position. Int2 mode of 1 equals immediate. Ilial parameter mode. So this actually... It's warning me, like, of a couple things. What's this warning about? Pattern matches are non-exhaustive. I didn't match output. You're right, I didn't. I didn't do that because I needed the reading function anyway when I was writing run bin, so I did those first. So output is simple enough, right? C, where outputs equals let param equal params, result equal read param mem in C outputs equals like so. No. Where's the memory? Oh, memory C. Oh, not C, but result. There we go. Yeah, don't give me that shit about this being a redundant bracket. Look how... Wait, are they both redundant? Okay, you got me. I guess they are, you're right. I'm still not totally used to treating infix things the same as operators, and so you don't actually need any... Is this yellow, like, as a warning, or just because it's a... Okay, yes, this is the last warning, just telling me I'm, like, importing prelude as p for no reason, but I'm going to use p.read eventually, so I have a reason, actually. Gosh. I feel like we should test something at this point, right? Like, we've done a lot. So let's do something simple like, you know, we'll take this program and, well, that's not a very interesting one, is it? There aren't any good example here's a program. Okay. So like, I don't know. The problem is we don't yet have a way to build computers from lists of ints. That's easy, right? Oh, hang on. I'm getting pretty good at noticing, though, when you guys aren't looking, and I get you over pretty quick, at least. So all we really need for a computer is, like, the memory. And we need the inputs and outputs. The inputs to be specified ahead of time. And then we initialize IP outputs and running to their obvious default values. I assume v.fromList exists. Zero inputs, nothing true, right? It's shadowing something. Ugh. So, okay, now make computer let me just grab these inputs. Oh, and in each of these cases, I just realized we didn't update the instruction pointer after running the instruction. Advance IP by not length params, don't be a weirdo. Num params of the operation. This, and we can write a pretty simple advanced IP, which is like equals C, where the IP equals IPC plus N. Yeah, that type checks. Try again. What I wanted to write was make computer of like this, right? And it wants a list of, oh wow. When did that happen? If you specify a value which can't be printed, it like tells you what type it has instead? Huh. Why are you just showing me? Computer has a show instance. I'm not asking you for its type. I want to know its value. Yeah, you told me 5. Oh, is computer not showable? Is that the problem? That is the problem. It's a computer. There's its memory. Okay, very, very nice. And let's put 0. So what if we now say decode next on this? It's an instruction. That instruction being an input. Input, by the way, being instruction number 2, not that that matters. And it has one parameter. And the parameters of the input are 4 in position mode. Is this complete bollocks or is this correct? It is complete bollocks, right? Yes. Why? Because opcodes 1 and 2 are add and mul, not 0 and 1. Okay. Now we observe that it's a multiply. Wanting 3 parameters. Reading 4 in positional mode, 3 in positional mode, and 4 in positional mode. So that's obviously incorrect. One of those is supposed to be in immediate mode. It would maybe have been nice if I had a function that just did this on a list of ints and didn't require it being a whole friggin' computer, huh? Easier to play around with. Oh, not instruction, but code. Now it's a multiplication, reading 4 positionally and 3 immediate. Is that what it was supposed to be? It doesn't actually like spell it out for me, but parameter modes are 0 for this, meaning it should be position, and then this, meaning it should be immediate. So position first, then immediate, and that's what we have. So decoding instructions works. Okay, so how do we execute? Okay. Oops, wrong window there. Let C equal this in execute. We get a new computer where we've tripled the value stored. Yeah, that's what it was supposed to be. At offset 4. Cool. And what happened to our IP? It went up by 3. It should have gone up by 4. So really, I should have advanced IP, add a 1 in there, because we'll just say that be num params, and implicitly there's one more thing to advance over, which is the opcode itself. Num params is taken. Are you kidding me? God, I hate these warnings about shadowing. Take that. I know a million synonyms. I'm a thesaurus. Okay, so like, great. Execute seems to work. It works for an instruction. Like, surely it would work for all of them, right? So let's say run to completion. This function from computer to computer. And run to completion is drop while running head drop while running iterate execute. Not close, huh? Why? Yes, execute doesn't just take a computer and do the next step. So we need actually a function called tick, I guess. Tick is a function from computer, which just decodes an instruction and then runs it. And now run to completion works. So tick C equals execute decode C, right? Now this kind of like makes me wonder, did I choose the wrong argument order for execute? I kind of liked the idea that it like took an instruction and returned a function from computer to computer in a way. But so far, this has been like in the times we've wanted to use execute, it's been more convenient to do it this way, because then you could write this, right? Kind of good, isn't it? Execute and decode next, where like the computer argument is like implicitly passed to both execute and decode next. I like it. It's fancy. In the same way we used zip and tail in a recent episode, I think yesterday. So I guess at this point, it's time to just try it and see what happens. I forget if I already downloaded my input. I guess it's, well, I need to like write a main, right? Oh, you know what? I don't need to import qualified prelude as P here because I'm not ever reading anything in this file. Nice. Something like this I had in mind. What are you mad about? Huh? In advent encode. Oh, I say module advent.encode. Fair enough. What? I mean, I'm definitely not an expert at using modules in Haskell, but I thought this was how you were supposed to do it. I have a file named intcode in a directory named advent. So shouldn't it be module advent.intcode? Modules. Module tree. Qualified names. It's not what I'm looking for. Module hierarchy. Hierarchical module names. This is not telling me anything. What's the right way to name packages and modules? I don't care about my package names. Module blah, okay. Hierarchical modules are frequently misused. What an exciting opinion piece. Huh. Well, I mean, I know one way to fix this problem, which is to like just not know what's going on at all. And move this file to the top level. File name, what? Oh, I need to also change the module declaration there. Delete this file. What? Why do you? Oh my God! Sorry. It's right. It's right there. Int code. I just want this committed so I don't like fuck it up and delete everything and have to start over. I would quit my YouTube career at this point if I deleted this entire solution so far. All right, I'm closing Emacs because I just don't trust that it understands. Yeah, see? It just like everything was right. It just like had cached an incorrect version somewhere. And so probably putting it in Advent would have been totally correct. Whatever. We'll just leave it as is for now. I guess I need data list split again, don't I? So I'm going to have to restart Emacs again anyway to add this dependency. Oh no, I have to run stack build to actually pull in the dependency. Closing it on 2 hours here. Oh. These modules. What? Okay, so I should put it in what? Oh, also I've suddenly forgotten. Okay, there we go. Yeah, there's a million non-exhaustive pattern matches in this one. I'm not fighting the linter on this. I'm intentionally doing lots of unsafe things. Missing home modules. So they're just saying, I see, that I'm not exporting this if I like publish this as a package or something, maybe? I'm not sure. So something like this. And our input type is a list of int. Was it not called split on? Data list split. Okay. So this all type checks, which is lovely. Mem equals I.out. I don't actually know what, I don't remember what output we're supposed to get. Just give me all the outputs and then I'll only look at the last one, I guess. Of run to completion. I make computer mem 1. Okay, this type checks, right? That's pretty cool. Exception. Non-exhaustive pattern in param immediate. Yeah. So this is sort of what I get for yeah, I really should not have everything be just not exhaustive with errors everywhere. I should like have a way of producing error messages. All the places where it's where I have an inexhaustive pattern match, at the very least, I should consider returning like, I don't know, right? Like this somewhere, you know, should be able to return a string or something. I don't know. But it just requires such a large rewrite. But it like is clearly very important to do. Where line 56 was the one that had a problem this time, right? Here. So what were our params? Yeah. This should be either string computer. And each of these should be able to return like an error if something went wrong. And I should say like case input C params of what is, oh, I see. Ugh, this is so gross. Yeah, this is actually not even that bad a rewrite, to be honest. Case, the things I need is just params, right? Params of where. Ah, pure. And I need to write the non-pure, the like the mismatching cases as well, but that one's easy. Case params of where. Okay, this goes like here. This needs a million spaces deleted. And we want a pure here. We don't really, do we? Update memory. And these reads should also return eithers. But okay, for now, we're like fixing some of the problems, right? Left. Oh, wait, no. Is that wrong? Are the parameters inputs C? I to I's, and the params should be a singleton list, right? I think that's fine. I don't know. I should be like left of invalid input like this or something, right? Okay, and now we just need I guess I want to drop y. Okay, first of all, I need to fix this. Now it'll complain about the type of running or something, or head, I don't know. It should complain about some of these, but I don't quite understand why it complains about iterate. Okay, there you go. Where okay of left anything equals false. Okay of right C equals is running C. Running C. Huh. That was the only problem. It just highlighted not the things I would have expected. Okay, so that'll help us a little bit with at least this very first error we're running into, right? Yeah. What? Unexpected response from Haskell process. Well, I guess we better friggin' quit Emacs again. I don't know. We can probably just kill day 5. Yeah, kill the whole session. No, don't kill associated buffers. What the heck happened to you, Emacs? We used to be friends. Okay. Yeah, a bunch of warnings, fine. It's not called run to completion, is that? Oh, right. We didn't handle the now it compiles. Okay. Invalid input. So it saw that there was one input available. And the parameter it got was 225 in position mode. I guess that makes sense because of what I was saying earlier when looking at like the definition of immediate mode is that like, or at input, right? Opcode, where does it tell me about inputs? It's always higher up than I think. Opcode 3 like looks like it's in positional mode, but you're supposed to treat it like it's in immediate mode, basically. So we should assume that it'll always be in positional mode, not that it'll always be in we'll just treat it like positional. It's just, I don't understand how you're supposed to work with multiple modules here. Oh my god, a number. Are you kidding me? First try? Question mark? Second try, I guess. I mean, it's 9 million and a bunch of zeros, which is what we were told to expect. It's the right answer. Praise be any deity you choose. So there's still some work to do. Sorry, here you go. There's still some work to do on this because like we're not handling as many errors as we should be. I just put in like the minimum number to catch the error I was having. But we can improve on this gradually. I think that's fine. Part 2. Oh no, there's more opcodes. The air conditioner comes online. Its cold air feels good for a while, but then the test alarm starts to go off. Since the air conditioner can't vent its heat anywhere but back into the spacecraft, it's actually making the air inside the ship warmer. Instead, you'll need to use the test to extend the thermal radiators. Fortunately, okay, we have the right program, but we need to add... So we have jumps. Okay. So, okay, we have two parameters. Oh, sets the instruction pointer to the value from the second parameter, either immediate or, whether that's immediate or positional. Okay. At the first, okay, that's not too bad, I think. So we have several additions to make here. Input output jump if true, jump if false, less than equals. Okay. Oh, I guess we should put those here. 5, and it takes 2, right? Yeah. And it takes 3. The two things compare and where to put the result. Okay. And we only have to adjust execute, I think. Right? Yeah. Excuse me, I need to sneeze here. That's the kind of high quality editing you get on this channel, right? I have a mute button and I don't want to bother editing, so just warn you ahead of time. Okay, right. So advanced IP is looking a little questionable at the moment. So I think what we should do is remove this +1, and remove like this, and put the advanced IP where it sort of belongs in the instructions that do it. And run bin can just advance IP4, right? Actually, wait a minute. I was thinking I would need new cases for the equality comparisons. But they can actually just fit inside of runbin, because they take two things and compute some function based on their result, right? Stores either a 1 or a 0. Yeah, easy. Okay, so let's do that. It's so easy, right? Less than is run bin of comparison less than. I know I spelled it wrong. Equals is run bin comparison equal. Comparison F. Comparison F returns a function of two arguments, so we're going to say comparison fxy equals bool 0, 1 fxy. Probably bool 1, 0 actually. We're supposed to say, let's see, if the first is less, it stores 1. So we want for less than, these are the same, of course, but sort of more evocative about the fact that f is a binary operator, not a binary function. So if f is actually less, bool will, we want 1, 0. No. Yeah. No. Because bool takes the arguments in the order false, true. So if x was less than f, we want a 0, and that means it needs to be we want a 1, and that needs to be the second case. Got it. And then we just need a jump. Why is comparison not in scope? This was indented wrong. No? Oh, this is attached to the halt. Very funny. Well, where was I supposed to put the where if I wanted it attached to the function? That's kind of weird. Wait, but no, run bin is attached to the right place. Run bin is attached to the whole. What? Did I just need to save or something? Did I spell them both wrong? I spelled this one wrong? Comparison. Okay. There we go. We just need a jump then. So our two jumping operators are jump if true and jump if false. Oh, actually, we say jump at 0. Let's, because the spec says if the first parameter is non-zero or if it's 0, right? So we shouldn't use Boolean operations. We should use operations that take an integer and return a Boolean. So not equals 0. And now we can write a jump function, right? Jump f equals case params of, we expect 2, right? A, B, basically. Then we say pure, well, there'll be a pure in there at some point, but pure of C if f read a memory C. I have memory C like lifted out a million times, don't I? Let's just mem equal memory C. Okay. Then well, let's say let new IP equal. No. Let new IP equal. Then oh, this isn't. Oh, I'm just doing these in a weird order. It's not the order they're written. I implemented less than and equals before I implemented jumping, and so I'm a little confused, but okay. So it either if the first one, if you should do a jump, it reads the second parameter, otherwise it leaves the instruction pointer alone and adds 1 instead. Then read b mem else 1 plus IPC in pure C IP equals new IP. I mean, it loads. So I guess we need to write part 2, huh? Okay, so we can just lift out this function here. Run is a function from value to either string int. Run in, well, I was calling it. Oh, it needs a memory as well. No, a list of int, which we turn into a memory, but isn't one yet. Actually, we can make it a list of value, it's fine. Wants an input, and this should then be be a list of value. Run 1. Okay, and part 2 equals run 5, basically, right? Oh, value doesn't exist. Okay, fine, you got me. They're both invalid. I messed something up. Really? What? It found that there were no inputs. But how? So we provided 5, and before we gave it a 1, right? I didn't get that wrong? Oh my gosh, there's so much scrolling to do. Pass 1. God only knows where that mistake came from, right? Make computer. Oh, did I get these backward? I don't think I did. No. It's just a complete mess that way. Well, I don't know. Maybe that was wrong. So what arguments? How does make computer want its arguments? Right. It wants a memory and input values. So it's supposed to be like this, and it like at least is it parsed correctly and just found there were no inputs in both cases for some reason. What's my input look like? Yeah, the very first operation is an input. Oh, you know what? I forgot to increment the instruction pointer in some other operations, I bet. Yeah, in like input, I didn't do it. Oh, this is like an old file or something, maybe? I'm like scared to open files now. Or, since I have this... No, I deleted the old one. Okay, we're fine. So the problem is that input and output don't ever go forward. Run bin do, jump does. Okay, let's try that again. Given key is not an element in the map. Uh-oh. That's the worst, because that one's kind of hard to convert to being an either. In the map, though, huh? So it's not actually a vector lookup. It's our opcode lookup. Well, that's maybe not as hard to fix. We just need decode next to return either string or instruction, right? You know what? Let's do. That's way easier. Except we're in either, huh? Data map. Query lookup. Yeah, it returns a maybe. So it isn't like parameterized by the monad or something, which would be a little nice. Okay, I guess I'll just put a case in here. This is a little gross, but oh, I'm already in a do here. That's fine. I don't want an in. So that gets us somewhere. Except decode next now. Now we can't use this cute little trick anymore. Ugh. Tick, C, boo, do. I'm just going to do it the lame way. Inster. This is the kind of thing that, like, you want a monad transformer for, right? Where you have like an either or T of a reader, basically, but whatever. I don't really, the reader was not really that good an idea anyway. Execute inster C, or C inster. Unknown opcode 25. I mean, I don't know where the first 25 is. Well, I guess it's like, oh, wait. Did I get the mods and divs right in decoding instructions? Or did I do something weird, maybe? Yeah, mod 100. It's hard to even know where this 25, like, okay. Offset 1. Oh! Yeah, sure. Because I had these advanced IP by 1, but it should be by like 2, right? Hilarious. What a thing to spend a bunch of time figuring out, huh? Unknown opcode 0 at offset 239. That's the kind of thing you're never going to be able to debug. The numbers, they're just too large. Okay, well, there are some example programs when they're teaching us about jumps. Wait, what is my in main when I read split on comma head lines? How many lines are in my input? 1. Okay. That's a lot of zeros in the middle there, isn't it? Kind of weird. That could just be like scratch space the program writes to or whatever, but just sort of stands out a bit. So, right, there's some larger examples. It would be kind of nice to run like part 2 on like the God. It copies with new lines in it. No. Part 2 of this and 5. Or not. Okay, so the example that they have here is give us the input, give it the input 8 and like see what happens, right? So oh, not part 2, but run. And it actually wants its arguments in the other order. Returns 1,000 if it's equal to 8. And it's supposed to return 1,001 if it's greater than 8. So let's pass it a 10 or something. Ooh, okay. So one of our comparison operators is probably incorrect then. Oh, yep. Where the heck are they? Jump. It's not 1 plus. It should be like 4 plus, right? Because we consumed, or 3 plus? Because a jump has, we're not just incrementing by 1, right? We're incrementing by the number of things we consumed. We had the opcode, the test, and the destination. So that's 3. There's a number. Great. All right, guys. I'm about ready to pass out and fall asleep. It's been like almost 3 hours here. But we did some good stuff today, right? It's a pretty okay, if I do say so myself, like int code simulator. There's lots of places to improve it, better error handling and so on. But it's a good start for the future days that are going to use this computer, I think. And relatively easy to use. And it was easy to add new instructions, right? Sort of. When we added these things, it was not too bad. Okay, hang on. Let's just commit this and go to bed. Really should not call that day 1, huh? Oh, sorry, you guys can't see. It's getting late enough that I'm no longer able to track what it is I'm showing you guys. Yeah, I realized I had committed as day 1 part 1 earlier, but it was day 5 part 1. So I went and rebased that out. Okay. I hope you guys had an easier time of it today than I did. And I hope you enjoyed watching me. Thanks for watching, and I'll see you next time.